Hello everyone and welcome to the second episode of the ForestHealth podcast, the official podcast of the FORSAID project. Here, as the name suggests, we talk about pests, especially forest pests, the danger these pests pose and how we might address it. I'm your host, Andree Cappellari. I'm the project manager of the FORSAID project and I work at the University of Padua. In our first episode, we talked about the damage that certain fungi, insects and nematodes can inflict upon tree populations with far-reaching consequences, both environmental and societal. Today, we want to move from problems to solutions, specifically the early monitoring and detection technologies that can really change the game in terms of preventing and managing outbreaks. After all, that's the vision of the FORSAID project. With that in mind, we have invited three specialists that have been actively exploring the innovations within the FORSAID project, and each of them will share their insights and experiences on these tech avenues. So let me introduce them to you. We are joined today by Stéphanie Horion from the University of Copenhagen, Matej Štefančič from the Slovenian Environment and Food Safety company EFOS, and Christian Pylatiuk from the Karlsruhe Institute of Technology. To all three of you, thank you very much for joining us today. Let's start with Stéphanie, our expert on remote sensing. What role can this type of technology play in forest pest management?
Thank you for the question, Andree. At Copenhagen University, we are using satellite remote sensing technologies to monitor forests and forest health in particular. Of course, you have to think that we can't see the insects from space. It means that we are actually relying on high resolution imagery and also high temporal imagery. So we can actually see multiple times the forest over a very large area. So we can have a large scale mapping of the forest health status at multiple times. And that means that we can actually do this monitoring and early warning or develop this early warning system for tree health.
And what about solutions on the ground? Matej, can you tell us something about the so-called smart traps that FORSAID is exploring for forest deployment?
I would maybe answer and give you a little bit of background as well, because I believe what is really, really important recently is that the definition what is good data, good insect data has changed. And it's no longer just I potentially have lots of data, but rather, is it reliable? Is it consistent? So I don't have to rely exclusively on the motivation and expertise of the people who work in the forest and collect the data. But can I get this data in a consistently good way? The second thing is it on time? Because basically what we want to avoid is that we analyze the data post festum, maybe at the end of the season, but we want to be in a much more timely manner. And the third one is it actionable? So it's not just timing, but also can it be processed and shown in a way that I can relatively easily derive the information from this data and organize my actions and in the forest, so that results in a better forest management. So when you combine all these together, and especially when you know that in forestry the last mile, the inapproachability of the locations is a big problem, then you realize that this is a perfect case for automation.
So we have already spoken about the need for efficient sorting and identification of harmful pests. So I think this is a great time to bring up the entomoscope. Maybe Christian can shed some light on this technology as it relates to our context.
Yes, thank you, Andree, for bringing up this question. At KIT, the Karlsruhe Institute of Technology in Germany, we work on the efficient identification of harmful pests. Let me give you some background. With conventional methods, this is very challenging for several reasons. There is a huge diversity of insect species. There are millions of insect species. Many look alike. Many pests look very similar to harmless or beneficial insects, and sometimes only minute differences in wing veins, in antennae or genital structures allow accurate identification. And distinguishing them often requires expert knowledge in entomology. So taxonomic experts use microscopes and identification keys, and the manual identification process is very time-consuming. This delays rapid pest management decisions, and we need scalability for large agricultural areas. And because of these limitations, modern approaches such as AI-based image recognition are needed to improve speed and accuracy in pest identification. And this is exactly where the entomoscope comes in. We developed at KIT this portable do-it-yourself photomicroscope for insects that images and identifies pest insects. Common insect species are already automatically recognized by the AI, and photos of pest species like the Agrilus beetles or the bark beetles, not yet known by the AI, were used to retrain and refine the AI models so that it now can recognize additional large target species from bulk samples.
Now that we have heard from all our guests, perhaps we can bring things together with a question to the whole group. Why is consistent and comprehensive innovation crucial to the effective management of biotic forest stressors like pests?
I think from the perspective of the remote sensing, as I said, we are not able to see the insect. So when you see the FORSAID project as a whole, we can cover the large-scale monitoring up to actually identifying or capturing the insect and making the identification of the species. And we really need that for us when we are looking at changes in forest health from space to be able to say, okay, this is actually insects related disturbance and not other type of disturbance. So that's why I think this comprehensive innovation in FORSAID is really needed.
Yeah, I would agree with Stéphanie completely, because I really believe that forestry is embracing digital technology, and not just technology itself, but also best practices. And when you look at FORSAID, in my opinion, some of the greatest minds in forestry are connected with this project at the moment. And it's a great mixture of research, but also the forestry policy implementators, So that provides a good feedback, what should be tried, what should be changed, and also what should be implemented. And at the end, you have here Christian, you have Stéphanie. It's the integration of those different approaches.
Yes, I strongly agree with you. Technology innovation is crucial for scalable and fast early detection and cost-effective defense against invasive pest species. The entomoscope allows for rapid screening at points of entry or in field surveillance within continuous surveillance programs. Within the FORSAID project, the entomoscope is being pushed beyond a prototype level, and we're training and refining the AI models on regulated pest species, validating performance against human experts, and testing the system under real-world conditions. That includes handling imperfect specimens and varying environments, which is crucial for practical deployment. And ultimately, FORSAID is about making this technology robust, trusted, and ready for operational use. And the entomoscope is a key step toward that transformation.
Once again, a very insightful discussion. I'm sure that our listeners learned a lot from our researchers, Stéphanie, Matej, and Christian. So we thank them for joining us, and we thank you all for tuning in. ForestHealth will be back soon with a third episode, but you can discover more information on forest plant protection on FORSAID website, www.forsaid.eu. Thank you all once again, and goodbye.